Namaste, children. In before class, you learned about the liquids and what are their properties, how they change from solid state to liquid and liquid to solid. You learned, and now we are going to learn about the gases. You can see the picture here. How the fumes are coming from a hot coffee cup. These fumes are in a state known as gases. So you're going to learn about the gases in today's class. So the here keywords are volume, space taken up by an object known as volume,
Space taken up by an object.
and compress, compress means squeeze or press something. If we send a small amount of gas into a small space, sending more amount of gas, that's known as compress.
Compress. Squeeze or press something.
Now to understand, we'll do one small activity. How do water and air act differently? We'll see now. So once see the video before doing the activity.
Fill the syringe with water. Now, fill the syringe with air. Try to push the plunger again. Both air and water take up space inside the syringe, but we can compress only air.
Once again, you see the video to understand more about the difference between water and air.
Fill the syringe.
Take an injection syringe and fill the syringe with water. When you push this back, it can take the water inside.
With water. Now
you try to compress. After filling, you try to compress it.
Fill the syringe with water. Now,
you cannot change the volume inside. You cannot press it. You cannot compress it.
Fill the syringe with air. Try to push the...
Now without water, you just push that syringe and allow the air to move inside.
Plunger again. Both air and water take up space inside.
So you try to plunge it. You try to push the plunger again, but you can move it very easily. But as in water, you could not move the plunger or you cannot compress. Yes?
The syringe, but we can compress only air. Fill the syringe with water.
How the gases are able to compress? Why can't we compress the water? Okay. What is the difference between air and water? How are they similar? Both air and water changed their shapes to fill up the syringe. They are changing their shape. Water is also taking the syringe shape only. Even air also taking the syringe shape only. None of them have fixed shape. Both do not have a particular shape. When we pushed the plunger, we could compress only the air but not water. Compress is nothing but in a little space sending more amount of gas. That we can do only for the gases. We cannot compress the water molecule. Water we cannot compress only. What are the properties of gases? What properties gases can exhibit? Gases have mass but no fixed shape, and they take up the shape of the closed container in which they are kept. They can take that container shape. Gases can flow in all directions. So a container to hold gases must be closed on all sides or the gas will flow out. That's why in our kitchen LPG gas cylinders are closed very carefully. Otherwise, the gas can freely can spread in the room. Gas can move very freely. So gases can flow in all the directions. So a container to hold gases must be closed on all the sides or the gas will flow outside. And gases have no fixed volume. How the liquids are having fixed volume. Both are not having particular shape, but liquids are having volume. But whereas gases even do not have volume, but they can compressed. Gases can compressed, but water can't be. Okay. Now some features of the gases we'll understand now. Have mass and take up the space. Do not have a fixed shape and volume. Flow in all the directions and can be compressed. So all these properties you can understand by doing the syringe activity. The plunger of the syringe, when we push the plunger, we could compress only the air. Right? You had seen this in the video. How we could able to push the plunger.
Fill the syringe with water.
So this
Now, fill the syringe with air. Try to push the plunger again. Both air and water take up space inside the syringe, but we can compress only air.
Okay, so that is the difference between gases and liquids. Ice converts into water on heating. What will happen if we heat the water? Definitely that changes into gaseous form. You know, when your mother is cooking food, hot fumes will come out when she boils the water for some time, right? So on heating, the water will change into gaseous form called steam. I showed you in the first picture how the steam is coming. This is nothing but when we heat the water, it changes into like steam. This is nothing but the steam when we are heating the water. But heat is compulsory in this case. When you heat, the water is changing into fumes. These fumes are also called as steam. Understood? So when you heat the water, that changes into like steam. What are the properties of gases you learned? What will happen if we heat the water? And it changes into gaseous form. If we cool the steam, again that steam will come back into the liquid form. This is true for all the liquids. We can convert liquids by heating them at certain temperatures and get them back to their liquid form by cooling them. You can see this. A kettle you take, and in front of the kettle, when you keep a cool plate, this hot vapors, when you heat this water, the water change into gaseous form, the vapors are coming out. So these vapors, again when they touch to the cool plate, they are changing into like water droplets, right? Here also you can see the same thing, how the water is changing into like fumes and again changing back into like water. Now see the worksheet. What questions are given in the 9.4 worksheet? We'll see now. Which of these are gases? Tick the correct one. Is the air is a gas? Yes, you can tick. Steam is a gas? Yes. Aerated drinks have gas? Aerated drink. Drink is a liquid, right? Next, football is not in gas state. Oxygen is in gas state. So whichever gases you put tick mark in front of them. Now the next question, the balloon is filled with air. Look at the picture and fill in the blanks. If we prick the balloon, the air will stay inside or blow out. Definitely when you prick this balloon, the air blows outside. Now B bit, air takes up the space shape of the balloon as it does not have its own shape. You know that the gases do not have their own shape. They take the container shape where they are, that shape they'll take. Write two properties of gases. Gases do not have a particular shape and do not have volume. They flow in all the directions. You can write these 2 points in your workbook page number 15 with your own words. Now, what is the gaseous form of water? When you heat the water, that changes into like steam. So the steam is the gaseous form of water. Steam is the gaseous form of water. So here you can write the steam is the gaseous form of water. This is just a hint. You can write by your own. Now how will you convert water into gaseous form? By heating. By heating it, you can convert water into the gaseous form. Same thing you can see in your kettle when your mother is cooking food, how the liquid is changing into gas form, you can see. Now we'll see what are the practice questions in this lesson. Before going to the practice question, from page number 21, you nicely read the lesson and then try to answer this. Circle the gases. Is air is a gas? Definitely. Oxygen? Yes. Water? It's not. Steam is a gas. So circle all these which are in gaseous form. Now draw a diagram to show that air does not have a fixed shape. You can draw a balloon and show that air is not having particular shape. It's taking the shape of the balloon. Now true or false? If we boil milk, it will reduce as the water in the milk will convert to gaseous form. Yes, when you boil the milk, they will be reduced in the volume because the water which is there in the milk that change into like steam and goes out. Now if we put oil in the refrigerator, it will become gas? No. To become gas, compulsory heat is needed. When you supply the heat only, any liquid will change into gas form. So in the refrigerator, you are not supplying the heat. So it will not come into the gaseous state. Understood? So nicely read this lesson and answer 9.4 and 9.3 children. Thank you.